Alright, welcome to lesson 4. In this lesson we're going to discuss an algorithm called k-nearest neighbors. It's an old algorithm, it dates from the 60s, and it's a very simple algorithm. It's a lazy algorithm. Why is it lazy? Because the only thing the machine does is store the label of the training samples. Now that's all it does. When we give it a new point, it will look at the closest training point next to this point, and it will give it the label. So similar points have similar labels. Another way to express this is if it walks like a duck and if it quacks like a duck, it is most probably a duck. Okay? So very simple. I have a point here, x test. I take a look at what point is the nearest to x test. That is this point here, point number 1. That means that I give x test y equals to 0 label, or a blue label. As simple as that. Of course, it's very obvious when you take one neighbor, but you could also take several neighbors. So what you mainly do then is you take the majority vote of the labels of the points in the neighborhood of the test point, and you may also weigh it according to distance. So you make sure that points further away have less influence. So you divide by d squared, where d is the distance between the points. Very important here, similar points. How do you define similar? Well, in this case we will take distance. Distance. In the linear algebra refresher, we have seen that there's two ways to express similarity. One is distance, the other one is dot product. So in this case we use distance. But distance can have many heads. When we think about distance, we usually mean Euclidean distance. So you have a grid here, point 1 and 2. The distance between point 1 and 2 is c. Now we use Pythagoras. C squared is a squared plus b squared. And a squared is this piece. This is y2 and this is y1. So a is y2 minus y1. Y2 minus y1 squared plus, and the point b is x2 minus x1. X2 minus x1, and also I square it. So that means that the distance between item 1 and 2 equals y2 minus y1 squared plus x2 minus x1 also squared. Okay? So in this case, y2 is that one, y1 is that one. So 2 minus 1 is 1. 1 squared remains 1. And x2 minus x1 is 3, and we need to square 3. So that is 9. So that means that the distance here is square root of 10. That's how you calculate the Euclidean distance between 2 points. Now there's other ways of expressing distance, and one of the other ways is Manhattan distance. Manhattan distance. What's the Manhattan distance? Well, it's basically a plus b. In absolute value. So a equals 1, and b equals 3. So the Manhattan distance in this case is 4. So that's how we deal with the metric distance. K is the number of points you look at in the training sample, and it could be 1, could be more than 1. So this is a parameter that a data scientist would need to choose. Yeah? So that's why we call this a hyperparameter. We've seen similar hyperparameters in gradient descent. The alpha, the learning rate, is also a hyperparameter. Well, here it's exactly the same.